Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC but do everything DIY. And today we got a service call for a water-cooled heat pump. Thank you to everyone tuning into Jumperman Tech, and today we are working on a heat pump. Here we can see our reversing valve, and right there, that gray tubing, that is our water-cooled condenser. So this unit is tied into a cooling tower. Here's our pull switch, and it is unplugged as I was told, and the plug is right there. So I was told the system is cutting on and off, so they unplugged it. A couple things to take note of is your surroundings. We are in New York, and today is 37 degrees, so it's a cool day. We have to keep in mind these systems run off the cooling tower. That is what supplies water to the condenser, so it's important to evaluate your surroundings before making any decisions. Let's go ahead and take a look at the cooling tower and see what's going on over there. Here are some controls for the cooling tower. Right here you can see cooling tower fan VFD control. So this fan is controlled by a VFD. A VFD is a variable frequency drive. So 0 RPM, motor speed. So they are not currently running the fan, which is a good idea as it is very cold outside, 37 degrees. Let's see. So the fan works off this temperature controller made by Honeywell. So let's see, that's what runs the pumps and the fan. Sensor A, 61 degrees. You see right there, could be a reason why this machine is cutting on and off. The water is very cold. We can easily be cutting off on a low pressure switch because of the water temperature, not exactly a gas issue, a pressure control issue. And we just dropped another degree. 60 degrees is very cold. Here's a look at the cooling tower. I can see the fans are not running, and we are pretty quiet here. Let's just take a look around to see what do we actually have here. So here are the fans. You can see that it's the shaft. Got some squirrel cage blades. All right, let's see. We have 3 belts here. Okay, we are not running, which is good. Question: do they have a heater on this tower? 60 degrees, it's very cold right here. That would be a heater. This piece here is our water level control. Here is a temperature controller with the bulb that's sensing tower water. Let's see what's going on here. So I just read the specs of this heater. Wait, what is that? The fans are starting. It's making a terrible noise too. All right. The fans should not be running with a 60-degree tower. That is freezing. That's no good. But I did get some specs off that heater. It's 208 volts, 3-phase. Follow this whip, goes into that box down there, and so does this temperature controller. So if this controller senses that the water is too cold, the heater should start. But if you got a fan running, well, you could forget about heating up that water. All right, so the fan just shut off on its own. I only seen it run for about a minute or two. It sounds absolutely terrible. Some new belts and some grease could do wonders here. Gonna have to make a recommendation for that. Let's see, we got 3 BX77 belts. That's what it's labeled here. These really shouldn't run and this cooling tower is just way too cold. Whenever there's notes, pay attention to it. So behind this control we have some relays. So it says the left relay works the pump and the right relay runs the fan. So fan start, they have it cycling 75 to 80, and for the pump you run at 7 to 75. We're at 59 degrees. It doesn't make sense as to why any of this had started. Should have never run to begin with, but it did. Have a feeling the issue here is going to be something with the cooling tower before I even evaluate the unit. So it's very important to understand your surroundings before hooking up gauges and things of that sort. So when you're testing equipment, I don't exactly recommend you use gauges with hoses, especially for tiny units like this. I recommend using these probes because every time you connect and disconnect your gauges, you lose some refrigerant. With these, you really don't lose much at all. So when you're testing and troubleshooting, I recommend using probes or an analog gauge that doesn't have a hose, or just the shortest hose you have. So I'm gonna hook these up to the high side and low side. These are also temperature clamps, wireless, super cool, connects to your phone. It's a great tool to have. So let's put that in, hook it up, turn the unit on, because for all we know, you know, there might be no gas inside here at all. I mean, I could see right there, it says leak. So always pay attention to notes, pay attention to your surroundings, use the right tools, and take things one step at a time. Be patient, you're gonna get there. You know, we charge by the hour here, so you know, we don't gotta be running like chickens with no head. So let's hook up our gauges. Here are 2 ports. So I hooked up my probes 1 and 2, and we do have the pull switch disconnected. But of course we can see something is strange here. We have a light indicating that we have low voltage. I've done a service call in this building before in this area, and I did notice that literally that unit right there with the wet switch, I have a video on that. Even with the pull switch off, I still had 24 volts here, and the transformer inside there was disconnected. There's 2 transformers in here. This one's disconnected. Oh man, well, let's see what's going on. But something strange with this whole line of units is that there's 24 volts coming to all of them, and none of them have like active transformers. What's that about? Not sure, but let's get down to the issue. That's been a mystery for the engineer since he came here many years ago, and nobody figured that out yet. Another thing to take note of is the system is cutting on and off. Could be a pressure thing, but you know, if your filters are packed and your fan belt is broken, you know, that would cut you off on low pressure, especially that fan. Those filters are black full of dirt. You can see a speck of blue. That's the original color. That needs to be replaced. I mean, look at the filter on here, completely packed. You know, this is the color of what a clean filter looks like, and you can see the difference. So be aware of your surroundings and inspect the unit, because all these little things contribute to the issue. Sometimes you see black filters, but those are charcoal. But I don't know if you can see that blue? Well, this is the original color, and I did find some filters here. Let's get these bad boys in there. This is very important. That is a beautiful thing right there. All right, so right now I have a temperature clamp on the water inlet pipe, and according to this, it's at 61.5 degrees. So that is accurate with whatever reading we have off the Honeywell control downstairs. that liquid line in here is very difficult to get to. It's all the way down there. So I just have it on the suction line as far as temperature, but I do have my discharge pipe connected and my suction. So let's turn this on and see what happens. Also, we have a 104, 105 standing pressure, and we are equalized. This is refrigerant 22. All right, let's plug in our pull switch. All right, nothing. We have nothing. Well, there's a good chance they might have shut the thermostat off as well. I'm not exactly sure which one it is. They have a kind of a strange setup here. Let's go crank these bad boys up. According to our probe, the water temperature just came down to 56 degrees. Now it's 57 coming up. I have a feeling that fan started. It turns on for a little bit and it makes the water even colder. All right, so this is the vestibule, front desk lobby. Can't be it. Mess south, mess north, no. Ballroom north, ballroom south. So it's either between 1, 2, or 3. So I set those to cool, and typically I do that because you're just more comfortable and aware with those cooling pressures. And wow, this place is so cool. So let's make our way back up there and see what happens. There could easily be a 5-minute delay. So the head pressure is actually climbing. What's going on? So this, hey, sometimes not what you think. Alright, so it started. My head pressure is way too high. Let's keep an eye on this. Back pressure is okay. We're not coming down on low pressure. It's not what it is. If anything, our head pressure is way too high for, you know, 60, right now it's 62 degree water. If anything, it should be the other way around. Since this is water cooled, they have strainers, which is this piece right here. So the strainer could be dirty, or we're not moving water. All right, so the system's running, but we have a 280-pound head pressure, and that is way too high for that temperature water. So just unplugged it. It's not good really to do that under load, but what's the big deal? I just turned off the contactor and that turned us off. So that is our strainer. Let's pull that. All right, inlet and outlet are closed. It's cool. This has a little valve here. All right, got the remaining water, and now we can pull this off. Oh yeah. Oh yeah. That could do it. That could definitely do it. A lot of sediment in there. Alright, so we're just gonna give this a rinse with some water. Some high pressure water will be good. And if you want to do a perfect job, use a little wire brush. So let's clean this up. So that is a difference. You can see right through it. That's a big one. All right, so we're back at the unit. I'm gonna put the strainer inside here. There's a rubber gasket around, so you don't need Teflon or anything. Just gonna tighten that down, righty tighty. Lock it down. Close this valve. Open those, have the water flowing. and bleed out maybe some of the water through here, and you really want to get to the top of the pipe, so if there's any air in the pipes which can stop the movement, you know, you bleed that out. And from there we're going to turn the unit back on and check the pressures. Alright, so I just turned on the unit. Let's give it 5 minutes to adjust pressure and see what happens. Hopefully this can build up right now, because now our pressures are very low and we just shut off, and that's got to be low pressure. And now the issue is just as we suspected, with the water being too cold. Let's give this thing a chance. Sometimes the pressure starts off low and it climbs back up. It is heating season. I just wanted to check pressures as far as cooling to see where we're at with the refrigerant. Let's see if this holds up actually in heat mode. Alright, so it's saying our water is 52 degrees right now. Water's at 52 degrees. It says here, and the same thing on my probe right there, 52 degrees. This water's freezing. This fan must have started, you know, out of nowhere. Unreal, man. Alright, so this unit's running right now. Got a steady green light. If we look on the app right here, suction's at 53 pounds, liquid line at 249. It's staying on, which is good. Sometimes they have trouble starting up. And let's see what temperature we're reading. Just gotta reset this. $104 degrees, 105. Well, really 104.9, but seems all right to me. Space feels warm. This is running. Thing is, this is a private ballroom that we saw earlier down there, and you know, they have pretty much everything off here. All the refrigeration that is water cooled is also probably satisfied, and nobody's opening the boxes, so there's not much of a load on this cooling tower. But I gotta say, this water is way too cold. Now see, this right here is actually reading the water here. 49 degree water, come on, no way. Before we get into the real winter weather, you're gonna want to make sure what that temperature controller is set at, to where it turns on that heater. You want to make sure that heater works. You don't want to be in a, you know, 0 degree day and that thing ain't working and you have a party here. Well, you can forget about cold drinks and heating. Man, this place is beautiful. Just want to take a quick look at what exactly is set here, because I seen the it was like 60 degrees, 50 something, like high 50s as far as when that fan started. So let's go to menu. Click right on program. It says relay 2 is the fan, so let's go to relay 2. Let's see what the set point is. What turns it on? You see 60 degrees. That's a problem. So what, when it reaches 60 degrees the fan starts, and then this water becomes super cold? You know, I don't want to mess with the engineer's things here. This is his building to upkeep, but I'm gonna tell him this set point needs to be changed. I'm not gonna touch it. I'm gonna go back to menu, exit. All right, because we can't have that fan coming on at 60 degrees. We want this to be at like 75 degrees, 80 degrees. So that fan shouldn't be kicking on. This needs to be, you know, adjusted for the winter time settings. So I'm gonna make that recommendation. I'm gonna tell him he needs to change those belts and grease those bearings on the tower. As we saw, it made a huge noise. We don't want this fan starting, really. That's one of the biggest things. We would have went off on high pressure if the pumps weren't running. We're still running, got 246 head. Let's just make sure those pumps are running, and we're gonna call it a day, and we're gonna make another service call out of this whole situation here and the cooling tower with the belts. And you know, we got to keep this place running. You need to have a load on that tower, or you know, there's no heat to reject, and it's just gonna get super cold, and we're gonna be tripping on low pressure on all these units. All right, we're in the dungeon. We're in the boiler room. Man, these things are old, super cool. So pumps, here's the chemical that they use, anti-freeze. All right, here's our two pumps. You can hear this one running, this one's running, that one's off. These cycle based on how many hours they run. And what is this, maybe like a little booster pump or something? But they have another pump here. Oh yeah, I hear that running. Yep. So we got the pumps running. All right, that's good. We got the pumps running. It's just that setting for the fan is strange. It's really not good. Let's see. Check the in and out pressures. So we got about 40. Hey man. About 40 and above, and then above the scale can't go any higher than 75. So we got a differential. Pump is definitely running. My unit's staying on, and yeah. So I just dropped that set point to 39 to see what would happen. You can see our fan ramping up. Turn that off. 60 was way too low. It's never gonna reach 75 on probably, but if it does, let's just set it at that. And he can configure this later, because right now we can't have that fan turn on. See, the fan is ramping down. We can't have that turn on how we saw it turn on. So let's just confirm that. We have 43-degree water, come on. So let's just make sure that stayed. Set point 75. All right, home. We don't want that fan coming on. 0 RPM. Good. All right, unit's staying on, and before something else happens, I'm gonna make a run for it. And that's all for today. So it's important to note that this is a water-cooled system, and you got to check out the water, really, especially in the winter time. That could be causing you to shut off on low pressure, but as we saw, this machine actually cut off on high pressure. Then once we cleaned the strainer, we brought the pressure down, then it cut off on low because the water temperature was so low. And then that was in cooling mode. We got it into heating mode, and you know, after a few tries, I guess it stays on, and I'm gonna let it be. The space is warm. We're getting warm temperatures out of here, and it's staying on. And I did my part here. I'm gonna have a word with the engineer about those settings, see exactly where he wants to set that at, but we can't have that fan turning on. Pumps are running downstairs, and then that pump setting for relay 1 on that Honeywell controller, that's actually another pump right on the cooling tower. So that's not the pumps that we saw downstairs. The ones downstairs, that's what's feeding all of these units, which is very important, and we're good to go. So until next time, if anyone found this video interesting or helpful, please drop a like, comment, and subscribe, and catch you all next time.